Okay, in 3.5, we're looking at nonlinear systems. We have solved systems before. One method was graphing, but normally we had two lines. In this case, we have what we call an ellipse and a hyperbola. We don't know how to graph those yet, but if we have the graph, we can still find the solution. Okay, if we have two lines, there's normally one solution, maybe no solutions are infinite. But for different types of graphs, we could have a different number of solutions. So one solution could be right here. The ordered pair there is 1, 2, 1. So one solution is 2, 1. But there's not just one solution, there's more than one. I also have the point down here. This point is 2, negative 1. What else do we have? This one up here, that's negative 2, positive 1. And one more down here. So we have negative 2, negative 1. So in this case, our system had 4 solutions. So it's possible with these kind of systems to get 4 solutions. Okay, let's look at the next graph. Okay, this is actually a parabola, which we know, and this is a line. But in this case, we still have more than one solution. If we look at the graph, one of the solutions is right here. The ordered pair would be 1, 1, 2, 3, 4. So 1, 4 is one of our solutions, but there is another solution. It's way over here. That's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 5, 8. So this one had 2 solutions. Okay, let's look at one more graph and then we'll do this algebraically. Okay, one more graph. We have a parabola and we have a line. So I see 2 points of intersection. One is over here. What is this? Negative 1, negative 2, negative 3, negative 4, negative 5, comma, negative 1, negative 2, negative 3, negative 4, negative 5, negative 5. And then what's my other point over here? That looks like x is 1 and 1, 2, 3, 4, 5, 6, 7. 1, comma 7. Okay, now that we've seen what the answers might look like, let's do it algebraically, keeping in mind that we could get 2 answers, we could get 4 answers, we could get 3, we could get 1. We have no idea, so we're going to go where the algebra takes us. Look back at your graphs. The first graph is actually the exact same equations we just solved, and this is actually what the graph would have looked like. It would have been this elliptical shape and this hyperbola, and there's 4 points of intersection, which is why we got so many answers. Okay, the first method we're going to use is elimination. Remember, elimination is when we add down and we try to get a term to cancel. This has all kinds of squareds and y-squareds in it, and we don't know how to graph it yet, so algebraic is our best option. Okay, if I look at them, they are lined up. I can see the y-squareds are going to cancel, so I'm going to go ahead and add down. 4x squared and x squared is 5x squared. Y squared minus y squared cancels. 61 minus 16 is 45. Okay, let's solve for x squared. So I'm going to divide by 5. Okay, make sure you bring down the x squared equals 9. Okay, we've never done a system with x squared, but we know how to solve this. We can square root it. Remember, because it was quadratic, we actually get positive and negative 3. Okay, which means I have 2 x values already. Okay, now normally we take our x value and we plug it back into the equation. It doesn't matter which equation we plug it into. Okay, the problem is we have 2 x values, so I have to plug them both in. So let me plug in x equals positive 3 first. Now it doesn't matter which equation I plug it into, this one or this one. I'm going to plug it in the first one, but you could do it in the second one. And I need to plug for x. X is right here. So it's going to be 4x squared plus y squared equals 61. Order of operations, 4 times 9. 4 times 9 is 36. Okay, what's 61 minus 36? 25. Okay, now to cancel the squared, I need to square root it. So I get y equals positive and negative 5. So after plugging in x is 3, I got positive 5, but I also got negative 5. So I already have 2 answers. Okay, now the problem is I didn't even plug in negative 3 yet. So I'm going to go and plug in negative 3. Doesn't matter which equation I plug it into. Okay, I'm going to plug it in the first one. So it's 4x squared plus y squared equals 61. Order of operations, 4 times 9. Oh, this is starting to look familiar, doesn't it? Okay, I'm going to minus the 36. I know it's going to go to 25 because it looks just like the other one. Square root both sides, and I get y equals plus or minus 5 again. Okay, but this time when I plugged in x is negative 3, I got 5, and I also got negative 5. So this system actually has 4 solutions. Okay, go ahead and try number 1 on your own. We're going to use elimination again. Look for something to cancel, and then don't panic when you get many answers. Unpause when you're done. Okay, these are my answers. I got 2, 1, 2, negative 1, negative 2, 1, and negative 2, negative 1. And if you're wondering, how the heck did I get so many answers? Okay, let's go ahead and try another one, and we're going to use substitution this time. Elimination would be a little trickier because nothing cancels out right now. But since I have an equation that says y equals x plus 3, I'm going to look at the first equation. I'm going to plug in for y. Okay, so x squared plus 2. When I get to y, I'm going to plug in x plus 3 plus 3x. Okay, and even though there's a lot going on, I'm just going to simplify it and then see if it turns into something I know how to solve. Okay, it looks like we have like terms here. We have 2x and 3x. So 5x, and then we have 6 minus 20, which is negative 14, equals 0. Now this is quadratic. If I can factor this, that would be great. Okay, to get negative 14, I'm thinking it's 7 and 2. The question is which one's positive, which one's negative. Okay, for it to add up to positive 5, I need a positive 7 and a negative 2. If I solve, I get x equals negative 7. I'm going to get x equals 2. Okay, I'm trying to solve for the ordered pair, so I need the y values. Because I got 2 x values, I'm going to get at least 2 y values. Okay, now I can plug this x is negative 7 into this equation or this equation. Okay, looking at these two equations, the second equation looks so much easier. I'm going to put it in the second equation. Okay, so what am I plugging in first? I'm going to plug in x equals negative 7. Okay, I'm plugging in the second equation. So y equals x plus 3, which is negative 4. So my first answer is x is negative 7, y is negative 4. Okay, but I also need to plug in x equals 2. I'm going to plug it in the y equals x plus 3. So y equals x plus 3, which is 5. So 2 comma 5 is my next solution. Okay, this one has 2 solutions. Okay, go ahead and solve number 2. Use substitution. Pause the video, unpause when you're ready to check your answer. Okay, I solved it out, and my answers are 5, 8, and 1, 4. Okay, so in this case, there were 2 solutions. If you want to see why there were 2 solutions, go back and look at your graphs. This should match your second graph. On the graph, we should have had the same 2 answers. Okay, let's try one more problem. Okay, I'm going to have you go ahead and try it. You can use substitution or elimination depending on which one was easier for you. Unpause when you're ready, and I'll try to put the solutions in both methods. Okay, now if you chose to do substitution, it's because you saw y equals this, and you went ahead and plugged it in there. Okay, and the only thing to be careful is when you subtract, make sure you put the 2x plus 5 in parentheses. It doesn't seem like it's going to make a difference. But because I'm minusing the whole thing, I'm minusing the 2x, and I end up minusing the 5, and which will change the sign and will change my problem. Okay, so using substitution, I got negative 5, 5, and 1, 7. This also matches the third graph. So if you want to see why that happened, you can look at the graph to see why it happened. Okay, now if you chose to do elimination, if you were staring at these equations and you were like, wait, maybe the y's do cancel. They do cancel. This is a negative y and a positive y. So I can add down even though everything's kind of discombobulated. If I do that, I get x squared plus 6x. The minus y and the positive y cancel. I lined up my equal signs. And then on the right side, I still have the 2x plus 5. Okay, it looks weird, but once I minus the 2x over, I get x squared plus 4x. And then I can also minus the 5 over. Okay, and then I can keep solving it like we did on the other problem. Okay, and then after this, I'm going to get the same answers I got over here.